Okay, here's number 8. It says a plane is designed for vertical takeoff. It has a mass of 8 and 3 zeros, so it'd be 8,000 kilograms. Find the net work done by all the forces on the plane as it accelerates upward at 1.0 meters per second squared through a distance of 30 meters from starting from rest. So the question is, what's the work done? Okay, let's see if I can put this right on top of the book. All right, so here it is. It doesn't matter what it is. I just drew everything as a box, right? Free body diagram. There it is. It tells us the mass, tells us the acceleration that is going zipping up. And here's my distance. I'm using D just because our formula for work is distance. We want to know what the work is. All right, so I'm going to write down the equation for work. It's force times the distance times the cosine of the angle. All right, so this is going straight up. So cosine of 0 degrees is 1. So this part here goes to 1. So it's just force times the distance. All right, so I have my 8,000 kilograms times the distance. I said 30 meters. So 8 times 3 is 24, and I have a total of 4 zeros. 1, 2, 3, 4. If you don't want to use that calculator. All right, so I have 24,000 joules. So here you can say 2.4 times 10 to the 5th joules. And there it is. Pretty straightforward, learning how to use that equation. All right, let's take a look at the next one. Okay, number 9. When catching a baseball, a catcher's glove moves by 10 centimeters along the line of the motion of the ball. If the baseball exerts a force of 475 newtons on the glove, how much work is done by the ball? All right, same thing, work. So here we go. Oh, they're giving us the distance is 10 centimeters and the force is 475 newtons. And we're going to assume the ball is going straight to the glove. Going straight to the glove. So the angle is going to be, again, 0 degrees. All right, so what's the equation? It's work is force times the distance times the cosine of theta. And we said the cosine of theta is 0 degrees, so this part's going to be 1. Now, notice that they gave it in 10 centimeters. For joules, it has to be Newton meters. So we have to change 10 centimeters to meters. All right, so if you don't see it right away, you can use your dimensional analysis for how many meters it is. Centimeter is 100 centimeters to 1 meter. Okay, so I'm going to move the decimal place over, how many times? Over 2 times, yeah? Or you can use calculator, 0.10 meters. There it is, 0.10 meters. All right, so now I can just plug it into the equation. The force is 475 newtons times 0.1 meters. I don't need a calculator for that. I just move this decimal place over 1, and so I get 47.5 Newton meters, okay, which is the same thing as 47.5 joules. Joules, okay, that's a J, not a 5. Okay, so that's a J. All right, let's take a look at the last one.